GD&T virtual condition. In this video I am going to show you how to calculate the virtual condition. I know that sounds really boring, but we are going to be doing this in as fun a way as possible and also easy to follow. Before we get started, please take a moment to like and subscribe. It's free and it'll help me out. Some of the examples are simplified to make them easier to understand and easier to follow along. I know what you're saying. What is a virtual condition? Well, I'm glad you asked. Virtual condition is the theoretical exact boundary condition of a feature of size generated by the collective effort of MMC and any applicable geometric tolerance. Don't worry, I'll explain it step by step. Our first example is going to be an internal feature. The example part has a hole which is 0.75 plus or minus 0.03. There is also a positional tolerance of 0.015 at MMC. Let's calculate our MMC. Our nominal size is 0.75 plus 0.3. So therefore, our MMC is going to be 0.078. Our geometric tolerance is 0.015. Now that we have all of our relevant information, it's time to calculate our virtual condition. Something to keep in mind, the virtual condition does not change with the given produced size. It is a static size that allows other parts to mate with this part. To calculate what the virtual condition size is, you need to take the maximum material condition and the geometric tolerance and add them together. So in our case, 0.78 plus 0.15 equals a virtual condition of 0.795. For this example, let's start out without a hole in our block and add our virtual condition first. So therefore, our virtual condition is 0.795. Now let's add the hole. So our hole at maximum material condition is 0.78. Therefore, the hole can actually be out of position by 0.015. The black circle in the center represents the geometric tolerance of 0.015. This will allow the hole position to be out by 0.015 in multiple directions. Now let's explore what happens when we produce the hole size smaller than maximum material condition. We get what's called a bonus tolerance. So in this case, we're going to use an example of us producing the hole size at 0.75. With our hole size produced at 0.03 smaller than our maximum material condition, that means we get a bonus tolerance of 0.03 plus our positional tolerance of 0.015. Therefore, we are allowed to be out of position by 0.045 in any direction. Let's calculate the virtual condition for an external feature of size. To keep things simple, I'm using the same numbers as I did for the internal feature. Our external feature of size is 0.75 with a plus or minus tolerance of 0.03. We also have a positional tolerance of 0.015. In this video, we're going to refer to the feature of size as a pin or a stud. Let's calculate our maximum material condition. So it's 0.75 plus 0.03, which equals 0.78. Our geometric tolerance is 0.015. Let's calculate our virtual condition. So we have 0.078 plus 0.015. Therefore, our virtual condition is 0.795. In this example, we're going to draw the virtual condition first. Then we're going to place the stud. Our stud is drawn in at maximum material condition, which is 0.78 in purple. Our positional tolerance is drawn in black at 0.015. The white dot drawn in the center represents the theoretical center of the part. At maximum material condition, the stud can be out of center by 0.015 in any direction. As the feature of size, the stud, moves away from maximum material condition, you can increase the bonus tolerance. In this example, we are going to change the size of the stud from 0.78 to 0.75. This will give us a bonus tolerance of 0.03. So with the bonus tolerance of 0.03 plus the positional tolerance of 0.015, therefore the stud can be out of position by 0.045 in any direction. Well, I'm glad to see that you enjoyed the video. If you'd like to see other great videos, check out my YouTube channel, Shop in Math. If you have any suggestions for other videos or comments on this video, please leave them in the comments section below. And as always, don't forget to like and subscribe. It's free and it'll help me out. All you have to do is click on the icon on my face and I'll do the rest. Thank you for watching the video. Have a great night.